Hello everyone, and welcome to today's Safety and Health webcast, How Big Data is Leveraged to Save Lives, sponsored by Predictive Solutions. My name is Kevin Drewley. I'm an associate editor with Safety and Health magazine, and I'll be moderating today's session. Thanks for joining us. We'll start the presentation in a few minutes, but first I want to go over some preliminary items. The views of today's speaker and organizations are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the Council or magazine endorses those items. At the end of today's webcast, we will conduct a question and answer session. To ask a question, simply type it in the text box in the lower left-hand corner of your screen and click the button for Submit Question. Feel free to ask your question at any time during the presentation. You don't have to wait for the question and answer session to begin. We'll try to answer as many questions as possible, but because of the large number of participants today, we may not get to each one. Any unanswered questions will be forwarded along to today's speaker. For basic troubleshooting information, click the Help button located on your screen. At the end of the webcast, you will be asked to complete a brief evaluation survey, which we will discuss further when the presentation is concluded. The webcast is archived, so you can access it after today's live event. To view this webcast and all of our past webcasts, go to safetyandhealthmagazine.com/events. With that, let's go ahead and get started. Our speaker today is Emma Stapleton, a senior data scientist within the Predictive Analytics Group at Predictive Solutions. Emma has spent the past 5 years building predictive models across the marketing and banking sectors. Emma holds a BS in statistics and a MS in analytics. Again, we thank all of you for tuning into this presentation. Emma, whenever you're ready, feel free to take it away.
Thank you, Kevin, for the introduction. As Kevin mentioned, I am Emma Stapleton with Predictive Solutions. Predictive Solutions is a software company based in Pittsburgh, Pennsylvania. We help companies save lives by predicting when and where incidents are going to occur. This webinar, I want to focus on how big data is leveraged to save lives. Big data is a large set of data which is analyzed to reveal patterns, trends, and association relating to human behavior and interactions. You either get really excited with that definition or completely overwhelmed with all of the possibilities. Throughout this presentation, I want to focus on the tools and people you need to simplify the data into something you are able to digest and act upon. One of those people you need to simplify your data is a data scientist. I'm going to go over what a data scientist is, how a data scientist is able to take your big data and help safety management, talk about a vision, strategy, and plan and the importance of in the management process, some prerequisites for success, and end with some closing arguments. If you Google the term data scientist, you won't get one concise definition back. This is one definition. A data scientist is someone who blends math, algorithms, and an understanding of human behavior with the ability to hack systems together to get answers to interesting human questions from data. There's a lot going on here, but you can focus on a couple of key words and phrases here. Math, algorithms, human behavior, and human questions from data. There's both a technical and a human behavior aspect to this role. Another definition. Data scientists are a new breed of analytical data experts who have the technical skills to solve complex problems and the curiosity to explore what problems need to be solved. You see some underlying similarities here with the previous definition. Analytical data expert, technical skills, complex problems, and curiosity and problems that need to be solved. Next, we took a series of resumes and job postings from data science. You see the keywords pop out of data science, but you also, if you look further, you see some more words like methodology and research. So if we go back to what a data scientist is, we're problem solvers. But more specifically, data problem solvers. Data scientists can be broken out into two words, data, and scientists. The scientist part is easy, math. We do math all day long. We typically have heavy backgrounds in math or computer science, and we use this math against all different domains. The data is what's variable. For example, Google. Google has a lot of data. They have a problem. They need to get an end user to come to the site, type in the search, and they produce relative links to solve their problems. Google has a lot of data scientists working for them to produce this solution. Uber. If you're not familiar with Uber, it's the application that's replacing taxi services in a lot of cities. Their problem is they need to pair the right driver with the right customer at any given point in time. They have data on not only the end users, but also the drivers of the cars. Amazon. In this instance, we're referring to the online marketplace. Their problem? They need to develop the logistics for a customer that needs to find the right product to deliver to them within a 2-day span. So why not apply this to safety? Safety collects a massive amount of data. Just in our database alone, we have well over 300 million observations. So if there's a large amount of data, why can a data scientist not do something with this data? The most important thing to remember here is that you need domain knowledge. A data scientist knows the math, but not necessarily how a search engine works, or how people behave when looking for a taxi, or how warehouses are set up to optimize the delivery. But by asking the who, what, when, why, where, they can get to that domain knowledge. This is done through a VSP. A VSP is a vision, strategy, and plan. The vision is the goal that you want to accomplish. Strategy is the logic to reach that goal. And the plan are the steps to reach the strategy. So we'll start out with the vision. What do you want to accomplish? We polled about 100 different safety companies to answer this question about what you want to accomplish. There were 2 overall themes: protect life and reduce costs. So now, taking that goal, you want to place it into your strategy. How do you reach your goal? Or more specifically, how can you protect life and reduce costs? We polled this question also. The 2 underlying themes were reduce and control risk. So moving on into the next part of your VSP, of plan. Steps to implement your strategy. Or more specifically, how can you reduce and control risk? This is done through measuring the risk. You need to, 1, understand your vulnerabilities and use that to mitigate any future risk. So now we have a more defined VSP, where your vision is to protect life and reduce costs. Your strategy is to reduce and control risk. And your plan is to measure risk and have an action plan. Now we want to focus on the plan of measuring the risk. How do you measure the risk? What metrics do you need to measure them? We break it up into 3 different categories of historical risk, engagement, and quality. Historical risk could be incidents or injuries, near hits, first aid or recordable injuries, but this could also include the body part that was injured, what caused the injury, any way that you define risk in your industry or in your company. Engagement metrics. How is the safety management team participating in the workforce? So what inspections are they doing? What observations are they collecting? And who is observing? And finally, quality. These are metrics about your inspections. How many are percent safe observations within the inspection? Are there late fixes? And also indexing. The next aspect to measuring risk is to define the granularities in which you measure it. Locations, work sites or workers or contractors, and observers. Location could be your work site, manufacturing plant, or however you want to break up your sites or company. Workers or contractors, these are the people out there performing the work, and then observers are the people implementing the safety management programs out there collecting inspections. So to review, we have the metrics, including historical risks, engagement metrics, and quality metrics about the inspection. But we also have the granularities of the location, the workers, and the contractors. So you look at this and you think, well, really, how much data is this? So we did a little study for this. In a given month, you have these granularities of locations, workers, and contractors. You can think of these as locations, workers, contractors, and observers. We need to determine what number of levels you have at within your company at the location, the workers and contractors, and the observers. The blue line here represents the average number of locations at our customers in a given month. For example, from 2010 to 2012, they averaged about 25 locations. It's been steadily increasing since that time, and at the end, now we are around for the past 12 months, averaging about 37 locations during the past 12 months for the average customer. We apply that to the number of workers and contractors, and on average, in the past 12 months, each company has had 77 workers and contractors that are working on their work sites. Similarly, for the observers, the average company in the past 12 months has had 93 observers per month. So if we go back to start to fill in that chart, we see that in a given month, there are 37 average locations, 77 workers or contractors, and 93 observers. That totals 207 data points. You can think of these as the columns in your Excel spreadsheet. But remember, you don't only have the granularity, you also have the metrics. In our database, we have about 6 metrics for historical incidents, 5 metrics for engagement, and 22 metrics for quality. You can think of these as the columns in your database. So you have 207 rows by 33 metrics or columns, and that equals 6,831 data points that you have to consume in a given month. That's a lot of data for one person. So the next question is, how much can you really handle in that given month? How much can your brain look at? So there was a study done by Professor Nelson Cohen to answer this question. The information you can hold in your mind at one time is the information you can interrelate. This is extremely important for safety management because you need to interrelate as much information as possible to understand when the next injury will occur. So getting back to that question, what's the answer? 4. 4 is much less than the 6,831 data points that you collect in a given month. This is the problem. When the mind's limit is 4, but the information to process is 6,831. So what do you need? A problem solver, or more specifically, a data scientist. So how can a data scientist help you? If you imagine on the left-hand side, these green dots represent each individual data point that we saw, 6,831 of them. Using our math and computer science backgrounds to interrelate and reduce dimensions to one singular data point. That one data point is a probability, or more specifically, a prediction. Prediction condenses information and puts it into a simple form. In this case, condensing safety metrics into a number to measure risk. That is the first part of our plan, to measure risk. So we can say now, with a probability, that you will have an 80% chance that an injury is likely to occur on your work site. Now you might see probability pretty frequently, say maybe in the weather forecast. If you see an 80% chance of rain in the weather forecast, you know that there's an 80% chance of rain. However, what if you apply that to the injury? If you're given a probability of an 80% chance of injury occurring, you might be on high alert for an injury occurring. This is what the probabilities are meant to represent. So in a report, you might have a series of projects like this sample. Now with those probabilities, you are able to assign a relative risk to each of these projects. For example, for RFK Bridge, there is a 95% chance of an injury occurring. But what else can you do with these probabilities? You can also start to group them. They'll fall in a scale from 0 as not likely to 100 very likely. You can start putting them into groups of high, medium, and low concern, and these are all determined by how you want to show it. They don't have to be put into 3 groups. They could, in addition, be put into 2 groups. It's all how you want to show. Now that we've started to define the custom groups, we can go back to the list of projects. We see that RFK Bridge has a red circle next to it. That's a high likelihood of injury, whereas OPD headquarters has a relatively low risk of injury. Therefore, you're able to rank them. This will help prioritize where to direct your efforts in the safety management meetings. Probabilities can also be used in trending. Are there certain parts of the year that are higher than others? Are there some spikes and dips? Does something seem out of the norm? This is where you can step in and take action if you see a probability for a certain project increasing and try and catch it before an injury occurs. Next, we can do some aggregation with this. This is a screenshot taken from one of our customers' reports. Each state has a manager that oversees a safety committee. As an executive, they can start to pinpoint where the problem areas are, with the red states being high risk and the green states being low risk. So going back to the plan, we want to focus on a way of measuring risk, and a data scientist can help you do that by taking all of the information and narrowing it down to one single probability. Once you have that probability, you can do a lot of things with it, including grouping, ranking, trending, and aggregation. Now, the second part of that plan was to create an action plan. What are you going to do with that probability, and how do you come up with that action plan? Each dot on this graph represents a single location or project that has had an injury. The metric 1 and metric 2 represent any of the metrics that you are collecting. In this case, we can use number of observations and number of inspections. And we can start to group these locations or projects by color. Each color has similar attributes. And we can start to define a profile for each of the groups of locations or projects. Here, profile 1 is high in metric 1 and high in metric 2, whereas profile 2 is low in metric 1 and medium in metric 2. We can take this concept and repeat for every combination of metrics that we have. We can start to develop a distribution for each of these profiles. For this, we took 7 metrics that you might have: percent inactive, number of inspections, and number of inspectors across the top, and contractors per inspection, observations per inspection, percent safe, and percent high severity across the bottom. The blue lines here represents the distribution across the 5 profiles that were determined. So if we start to think back to the profile 1 from earlier, where it was high in metric 1 and high in metric 2, we can see that these highlighted bars are the attributes of that profile or that group of projects that fall into that profile. We can look across the metrics as a whole and realize that the top metrics are all about engagement. The top metrics are all about engagement. They have high inactivities, low number of inspections, and low number of inspectors. This is a low engagement profile, and which consists of low engagement projects. The bottom right include metrics around percent safe and percent at risk. They have a low percent safe and a high percent severity. These are pretty risky projects. Finally, we have some density metrics. Contractors per inspection, or the number of entities being observed in the inspection, and observation per inspection, or the detailed pieces of inspection. They're high on both, meaning that these projects are not doing focused inspections. We found that it's better to perform smaller, more focused inspections rather than large ones that do not focus on a certain area. Putting all of this information together, projects in Profile 1 have a low engagement high number of at-risk, low number of focused inspections. Knowing this, we could partner up with safety professionals to create an action plan and identify best practices to move away from this trend. So the first part of the plan was to identify ways to measure risk by condensing it into a singular probability. The second part was to come up with an action plan, which is done through profiling projects based on historical metrics. Once grouped, we can work with different safety professionals to help create action plans or next steps to help change the behavior. But we can take it one step further and expand the concept. This is the list of projects that we previously reviewed. We talked about giving each project a probability, talked about the color coding and the grouping into high, medium, and low. And the risk column is the chance of having the injury, which might seem a little vague here because you're not exactly sure what that injury is. So this is where we can start to expand it into what's the chance of a recordable injury occurring. RFK Bridge has a 95% chance of having an injury, but only 41% chance of a recordable injury, whereas National Harbor has an 80% chance of an injury and 79% chance of a recordable injury. This will help safety professionals realign resources and put it where they see fit. Another step further, and you can start to look at the body part that would be impacted by the injury, whether this is arm, ankle, back, eye, or leg. What you can then do as a safety professional is go back to your work sites and understand what type of work would be causing this back injury. Is it something due to lack of training? Are there relatively new people on the project site? And you start to think, well, what could possibly cause this back injury? So finally, we can also expand it into the actual cause. This is where the profiles really start to develop. For example, National Harbor. We have an 80% chance of an injury, 79% chance of a recordable injury. That injury is likely to be a back injury caused by a slip or a trip. Now, marrying this information up against what the action plan could be is the next step in where safety management could go. We take all of the information, all of the observation data we collect, letting a data scientist pare down into something more meaningful, and using prediction to generate this type of profile that you see here. Generating this type of profile is all great, but there are some prerequisites you need before getting to this point. On the left is kind of what you want, the nice new building, and on the right is what you want to avoid, a pile of rubble that you're not able to do anything with. We've defined 3 prerequisites for success in order to create those types of profiles. If you're building that large skyscraper, the data quality is the foundation for that skyscraper. One question that we always ask is, are you actually predicting, are you actually depicting what's going on in your environment? Or is there someone that is going out there to just pencil whip and get their inspection done just to do it? You need to make sure you get a true depiction of your work site. Are you capturing every category of work or just picking the easy PPE stuff on the site? Is everybody trained on how to identify the safe behaviors? Just like the old saying, it's garbage in, garbage out. If your data is not depicting your actual work site, the prediction will not depict the actual work site. Engagement. Are all levels of the management in the workforce participating? Every worker from the front line to the VPs should be focused on safety. Everyone should be engaged in having these conversations around safety. So if you get data quality, if you get good data, and are engaged, you also need a good way to review the data and information. That is done through a data use plan, which is how you will collect the data and how you will use it. And it's also letting the data have a seat at the table. This is taken from one of our customers who developed that. They let the data have an answer or have a decision. Too many times, decisions are made by gut instinct. If you go through the trouble of collecting your data and identifying it, you should let it have a say in the decision. In closing, I want to focus on the importance of the data quality. You need to make sure your data is accurately portraying the worksite. You have to have an adequate VSP, which is extremely important in understanding processes and making sure everyone is following the same path. Data scientists can plan out the problem, and safety professionals are able to bring great value in structuring what their VSP is for reducing workplace injuries. Prediction can simplify your life and save others by grouping, trending, aggregating, ranking, and creating those profiles. Engagement is needed at all levels, all the way from the front lines through executive management should be thinking about safety. Finally, having an adequate plan to review and interpret the results. We cannot stress enough the data use plan. If you go through the effort to collect it, you should go through the effort to use it. I'm going to end with letting your data, trusting your data, and letting it have a seat at the table. That is all I had for now, so I'll open it up to questions if there are any.
Yeah, absolutely. Excellent. Great job, Emma. We appreciate your insights and expertise. Before we start the Q&A, just want to remind everyone of the evaluation survey we're asking you to complete. The survey should be appearing on your screen. Your input's important because it'll help us improve future webcasts. If you do not see the evaluation survey on your screen, please turn off your pop-up blocker. You may also access the survey by clicking the survey button near the lower right part of your screen. And now we will get to your questions. And again, just a reminder, the Q&A tab there at the bottom left-hand corner of your screen if you're getting anything come in frame of mind now that the presentation is complete. First, we have, how do you know if a company is ready for a predictive model?
Good question. Well, first you have to have the data. That includes both the leading and lagging indicators. The leading indicators would be the metrics that we talked about, and the lagging indicators would also be the incidents we talked about. You also need to have a developed BBS program, so it's something that you've already collected the data with. So until you're at that point of actually having the data and successfully using the data in some aspect, we think you would be ready for a predictive model. You also need a couple of years worth of data. We like to say at least 1 year worth of data, just so we can, but prefer 2+, just so we can evaluate the seasonality of the data.
All right. Thank you. No, you just spoke to a little bit of the next question there and the conclusion of your remark, but also had the question just how much data is needed. You spoke in terms of years, but is there anything quantifiably that you want to see that you have?
Sure. So what you need, as in addition to the amount of data, it's the type of data that you need. So you don't only need the at-risk behaviors, but you also need to be able to capture those safe behaviors. So you have to have both something that has gone bad, but you also have to have what has gone well, so we can predict what goes bad.
All right, the next one, just kind of leapfrogging off each other, but how do you know if you have good quality data? What are some things that you want to be looking for and making sure that's there?
Sure. So you don't know what kind of data you have until you try. So we can give it, as data scientists, we can give it kind of a sniff test of whether your data would be predictive or not, but also you have the domain knowledge to understand kind of what your data is and what you are collecting. So it would be a combination of kind of understanding and trying things out with the combination of a data scientist and the domain expert.
All right. You mentioned removing, the gut instinct and how that's so prevalent, but I guess what are some strategies you have to remove that consideration and to, like you say, to let your data have a say?
Sure. So there can be a lot said for gut instinct because it's something that you've kind of looked at and gone by for past decades. But the data is telling you something. It's not going to tell you everything. Just like you would be able to digest those 4 data points to interrelate and not the 6,831. So you should take the data and take the output and go back to your work sites and use your domain expertise to identify the areas of improvement.
Okay, thank you. Next one, do you consider shift work and fatigue factors in your model?
Yes, absolutely. So the any variables that you currently have, we would be able to put into the model. So whether that is shift work, maybe longer shifts might have more injuries, or how many days it's been since the last day off, or even project expertise. Have they only been on the project for, this is their first day on the project, or is the project consisted of a lot of veterans working for them?
All right, the next one comes. What are some of the softwares or programs you recommend to use for data manipulation?
So we use a lot of open source for data manipulation. So starting out, just Excel. A lot of people still use Excel. We tend to use more coding languages like Python, but there are a lot of different products that you can use for strictly the data manipulation part of it.
Alrighty. Have you incorporated non-traditional safety metrics into the model, such as maintenance or operations metrics?
Yes, those can definitely be incorporated into the models because the way that a machine works might impact whether a person might get injured on it. So as far as possible sensor data, we can use that, and kind of jumping from that, more third-party data, which would be like the weather data, what's going on in the environment. So anything to describe kind of the environment of the project. So whether that's density of the project or sensor data from machines or even weather data.
Okay, next one. Do you suggest a standard model, or is there a need for individual companies to have a model custom to them?
So if you have we will build a model based off of your data. So it would be a custom model developed just from your data and only the trends from your data. What we can use, though, is what we've learned from other models. So if there are important variables that we've found prior to that, we will ask for that in kind of the data collection process. So we will learn from other models, but the model will be strictly off of your data.
Alrighty, next one coming in. Are there any case studies published publicly that someone can look at just that explore how to measure a health and safety risk and how to use the data collected to come up with the action plan to reduce this risk?
So I'm not sure of any published, but if you would like to reach out to me after this webinar, I can definitely walk you through a demonstration of what we will be able to provide more.
Okay. Can you recommend any software or templates that can work for various industries to start working on collecting and planning data?
So collecting data, we have our Predictive Solutions is the software company called SafetyNet that you would be able to use to collect any sort of inspection data or observation data that's not necessarily only for the safety industry, but any other industries that you are in.
Okay. How long does it take to build a good predictive model?
That determines, so as far as, I'll answer kind of two questions from that. One is by data, so how much data you have, or the timing from start to finish of a model. So how much data you have, like I said, we prefer about 2 years or more. But timing of start to finish of a model really depends on what state your data is in and how much manipulation. As I say, it's data manipulation and prepping the data takes about 80% of the time. So making sure everything is aligned and we are able to build the model at the level that you need. So that is all dependent on the state of your data.
Okay. Next one is a clarification of something you'd spoken on earlier. When you had presented there the body part and cause, was that looking at past accidents and pulling that information forward from your accident data? And so, you know, as an example, the example of the back and slips and trips, that they would come as the highest from that accident data.
Correct. So you can kind of look at those models as completely separate models. So whether there is a high likelihood for a back injury or a slip and trip, those are completely separate models that are based on the past incident data.
All righty. The next one, just how do you mentioned calculating the probability of injury, and there was the chance of injury, but also the chance of the recordable injury. I guess how do you differentiate, or just what do you consider? Because those are two different pieces of data.
Sure. So that would be something that you would tell us. So that would be within the data that was sent, whether the injury would be classified as a first aid injury or a recordable incident.
Okay. Here's another one coming. Do you create a model and keep it, or how often should you reevaluate the model?
Good question. So once we create a model, we go through a maintenance process for the model. So we'll keep track of how the model is performing. And if we notice that the model drops below a certain threshold that either we set or that you set, then we will be able to evaluate the model and kind of retrain it, because sometimes models will fall off just because the kind of the past metrics aren't necessarily what's happening now, and the past trends aren't the current trends. So that's a continuous iterative process that we track and we identify and we evaluate.
Okay. Next one. Where would you get data from a particular industry?
Can you repeat the question, please?
Sure. Yeah. Where would you get the data from when you're dealing with a particular industry?
So how we would get the data would either, and I believe I'm taking this correctly, and please respond if I'm not. So if you have a in-house kind of data collection tool, you would be able to export that, and we have ways of kind of getting the data from your in-house tool over to us.
Okay. Well, that is appearing to be all the questions that we've received from everyone. We appreciate your attendance. Should anything come to you here at the last minute, we do remind you that any unanswered questions will be forwarded on to the speaker. Just a last reminder, we hope you take the time to fill out the evaluation survey on your screen to give us your feedback. And with that, we end today's Safety and Health Magazine webcast. I want to thank Emma Stapleton, everyone at Predictive Solutions, and all those who listened in. Thank you and have a great day.
Thank you, everybody.